All right, so yesterday we learned about the two forms of quadratics. Okay, here we had our, we'll call this from here on out, this will be the expanded form, okay, and we'll call this vertex form. I'll stay away from using standard because it switches back and forth. So if I want to go from vertex to expanded, really that doesn't do anything for us because vertex is nice because, like we said yesterday, the point HK is our vertex, right? So this tells us something about our graph. Actually, two things. And then we have the line x equals h is our axis of symmetry, right? So if we have a quadratic in this form, we know pretty much half the graph. So part of the thing that we're going to have to do is, figure out what a graph looks like depending on its equation, or going reversely, using the graph to get the equation. So again, this gives us automatically two things: the vertex point, and the axis of symmetry. Now what's nice is the vertex is always going to be equidistant from our x-intercepts. Okay, so remember, x-intercepts are when your y equals 0, what are your x values? Okay, so we have three cases when we're talking about quadratics. Okay, we can have two x-intercepts. Okay, when the graph crosses twice, like most, I don't want to say most times, but majority of the time it'll have two x-intercepts. And then, like I said before, our vertex is going to be the same distance from those x-intercepts. Okay, it's always going to be the midpoint in between. Our second instance is when we have one x-intercept, and that's when our graph just touches once. And we may have a case where the graph will never touch the x-intercept, and we don't have any x-intercepts. Okay, now last year you should have learned about imaginary numbers. That's where that comes into play. Here we would have an imaginary solution because it doesn't cross on the real axis. So one thing you're going to have to do is identify the x-intercept and vertex. So when you're given the graph, it's super simple, right? The x-intercepts where they cross the x-axis. And our vertex, we said on Tuesday, will either be the maximum, right, if we're facing down, or it'll be the minimum if we're facing up. Right? So if we have a graph, it's super simple, pretty straightforward. If we have an equation, though, it's slightly different. Okay, so if we are in expanded form, which is, most of the time you'll see quadratics in this form, there's two ways that we can find our vertex. There's really only one way to find the x-intercept, and that's by setting equal to 0 and solving, but we'll get to that probably either tomorrow or next week. But today we're going to find the vertex. The first method Okay, we're going to be using complete the square. All right, so I'll go over an example here. So uh, okay, yep. All right, so the first one is going to be completing the square. So remember, to complete the square, what we're going to do is we're worried about these two first terms, okay? And we're going to put those in, we can put those in parentheses. And then we're going to leave that constant term off to the side, right? Because, I mean, we may be able to factor this, right? Two numbers that multiply to 8 and add up to 6. But that's not what we're looking to do right now. We're looking for the vertex. So what I would suggest doing is rewriting it with a space. Okay, so you're going to rewrite the x squared and the x part. So x squared minus 6, leave a space, close your parentheses, and then put the plus 8 afterwards. Right, so remember, for completing the square, right, we want something that looks like this, right? X plus or minus some number so we can square it. So we look at our x value there, right? So we have to take, I don't know if you remember this, we take, I'll put it over here, half of b, and then we square that, okay, right? And here our b term is next to the x. So we're going to take half of that and square it. So we do half of 6 is 3, and then 3 squared, let me write it out, is 9. Okay, so I'm going to add 9. Now it's always going to be addition. I can't do this by itself, okay? I don't have an equivalent equation now. Whatever I do inside, I have to do the opposite outside, right? So if I simplified and I did plus 9 minus 9, I'd end up back with my original function, all right, which is what we want. I don't want to change this function. I just want to manipulate it. So now we have this x squared minus 6x plus 9. Okay, this is a perfect square, right? Two numbers that multiply to 9 and add up to negative 6 would be negative 3, x minus 3, x minus 3. On the outside, we're just going to simplify. Okay, so positive 8 minus 9, that's going to get us a negative 1. So we rewrite this as a square, right? Something like this. So we're going to have x minus 3 squared. And then on the outside, we're going to keep this combination, and we'll have a minus 1. All right, and now we are in vertex form. So from this, we go back to our vertex form, right? And I'm doing the opposite sign of h, and then k, whatever that value is, that's what we pull out. So here, my vertex is going to be at the point 3, negative 1. All right, and we can always double check to see if we're correct by graphing it. Right, so let's pull up the graph. Let me type it in first. X squared minus 6x plus 8. Okay, so here we have x squared minus 6x plus 8. And again, our vertex is down here at the bottom, and it is at the point positive 3, negative 1. Right, and that's what we got here, 3, negative 1. Now again, if I want to find the x-intercepts, which we'll do later, right? We set equal to 0, and we solve like we normally do. But we'll save that for another day. Now the other way to do it is we have a formula to find the maximum and minimum. Now, I'm not sure if you went over this last year, if you talked about quadratics. It's been a while since I've done Algebra 2. But in the process of doing this, okay, we use this b over 2 squared, right? So that kind of is going to help us find the max and min. To find the max or minimum, okay, the x value is found with the expression negative b over 2a. Or more specifically, we can say our axis of symmetry is the line x equals negative b over 2a. So if we go back to the previous example, right, I'll keep this up, x squared minus 6x plus 8. Right here, my b is negative 6. My a is the term in front of the x squared. That's going to be 1. So we plug this in to the negative b over 2a. So just be careful because this negative's out here. So I'm going to write negative 6 over 2 times a, which is 1. So that's positive 6 over 2, which is 3. So I have my axis of symmetry at 3, right, which is also our h value. Okay, going back up here. So we have that. Once we have this, we just have to take what we found and we can plug it in to find our y value. So now I'm going to plug in 3 into my function. Okay, so I'm doing 3 squared minus 6 times 3 plus 8. So this would give me 9 minus 18, which is negative 9. Negative 9 plus 8 is negative 1. So we have the x value is 3, my y value is negative 1, and again, we found our vertex. All right, so this was a nice example, okay, because there was nothing in front of the x squared, but that's not always going to be the case. So I do want to go over one example where we don't see that, and then we're actually going to take it a step further. We'll see if we have enough time, and we'll solve for our x-intercepts. All right, is everybody good? Can I change the page? All right. Oops. Okay, so we're going to identify the vertex for the equation negative x squared minus 4x plus 21. So in order to complete the square, our x squared has to be alone. Right? So I don't want anything else in front of this x squared other than a 1. So right now it's a negative 1. So we have to change that. So what we're going to do is we're going to factor out a negative. But again, right now I'm only focused on the first two terms. I'm going to pull out a negative from the x squared and from the 4x. So that's going to make it a positive 4x. I'm going to leave that space there because I know I'm missing something. And then I have this plus 21 out here. All right. So we go through the same thing of completing the square. So we take half of 4 and we square it. Luckily, that's going to be 4. Now, what we do on the outside, here we have to be careful because what I'm doing on the inside is being manipulated by this negative. So actually, another way we can write it, right, instead of doing it on the outside, is I could put the plus 4 minus 4 on the inside here, and then I still have this plus 21 on the outside. So now this part, these three terms will give me my perfect square. This negative 4 is being manipulated by what's on the outside. That's a negative there, which is a negative. So I'm taking this negative 4 out of the parentheses, but along with it goes this negative. So in the front, I still have the x squared plus 4x plus 4. Now out here, I have minus negative 4 plus 21. Okay, so again, this negative got brought out here, but then this negative came along for the ride. Okay, so if you factored out 2 from about up here and you had a 2 out here, you would multiply that 4 by 2 because you're pulling it out from the parentheses. Now again, we just simplify. So this becomes x plus 2 squared. That was pretty simple. Now out here, we're going to have minus negative 4, which turns to positive 4 plus 21 plus 25. All right, so now we have our vertex at the point negative 2, 25. Again, remember, we always take the opposite sign of the inside as our x value, and then the outside stays the same. Okay, real quick, if we did it the other way, negative b over 2a, just be careful because there's a lot of negatives here. So we have negative 4 over 2 times negative 1, right? Because that's what's in front. And that, in fact, gets us negative 2. And then if we plugged in negative 2 here, we would get 25. All right, we got 6 minutes. I'm going to go. We're going to do one example of finding the x-intercepts. Now, normally, you would go up here, right, and you would try to factor this. What are two numbers that multiply to 21 and add up to 4? Right, so you would break it up. You'd have, 7 and 3, and you'd figure out which one's which. Okay, but it might be a little easier to deal with this. So let's take a look at our vertex form. I have x plus 2 squared plus 25. Now, remember, to find the x-intercepts, we're going to set y equal to 0. So this is equal to 0. Now we just go about solving this normally. I subtract 25 from both sides. X plus 2 squared equals negative 25. I need to get rid of the square, so I'm going to take a square root. Now remember, anytime we do that, we have to do the plus or minus. But here we encounter a problem. Underneath we have a negative. So we don't have any real solutions. Okay, but if you remember from algebra, we can get rid of this negative underneath the square root with an imaginary I. And then things work out nicely because the square root of 25 is 5. So right now we have x plus 2 equals plus or minus 5i. And then we subtract 2. And there I have my two solutions. Negative 2 plus 5i and negative 2 minus 5i. All right. We'll come back to this stuff when we do later factoring and stuff, but I just wanted to show you that. All right. But really what I'm focused on is finding the vertex right now. Now I'm going to put up 1 or 2 questions tonight. You can use whatever method you like. All right. If you like this, negative b over 2a, and then plug that in, that's a little quicker than doing completing the square. But if you like completing this, if you like completing the square, I'm not going to stop you from doing that. All right. So like I said, you probably have 1 or 2 questions tonight. Find the vertex of this equation. Any questions?